Compare the standard reduction potentials. E degrees the standard reduction potential for the reduction of copper, 2 ions, is E degrees equals 0.34 V. The standard reduction potential for the reduction of chromium, 3 ions, is E degrees equals minus 0.41 V. Identify the cathode, reduction, and anode, oxidation in a spontaneous redox reaction under standard conditions. The species with the more positive standard reduction potential is more easily reduced and will run in the forward direction as the reduction half reaction. Cu to the power 2 plus 2 e to the power negative gives Cu quad E degrees red equals 0.34 V. The species with the less positive, more negative, reduction potential will be forced to undergo oxidation, meaning its half reaction must be reversed. Cr to the power 2 plus gives Cr to the power 3 plus e to the power negative quad E degrees ox equals plus 0.41 V. Balance the electrons transferred. To combine these half reactions into a balanced net ionic equation, the number of electrons gained in reduction must equal the number of electrons lost in oxidation. Multiply the chromium oxidation half reaction by 2. 2 Cr to the power 2 plus gives 2 Cr to the power 3 plus 2 e to the power negative. Combine the half reactions. Add the reduction and balanced oxidation equations together to cancel out the electrons. Cu to the power 2 plus 2 Cr to the power 2 plus gives Cu plus 2 Cr to the power 3 plus. Calculate the standard cell potential. E degrees cell equals E degrees red plus E degrees ox equals 0.34 V plus 0.41 V equals plus 0.75 V. Because E degrees cell is positive, E degrees cell greater than 0. This reaction is thermodynamically favorable, spontaneous, under standard conditions. This perfectly matches option B. The correct answer is option B. Cu2 plus 2 Cr2 plus gives Cu plus 2 Cr3 plus.